As we know that 2025 has been touted as the year of generative AI in production and also agentic AI workloads in production. And we can see a trend where customers are trying to put their workloads in production, and they're facing a couple of interesting challenges. The first challenge they're facing is their costs are increasing. And the second challenge which they are facing is that latency is also increasing at the same time. Looking at that, we decided to solve this problem by presenting Amazon Nova family of models at the last reInvent. My name is Vikesh. I'm a principal GenAI specialist solutions architect at AWS, and I'm joined by my friends from AWS and TP-ICAP. I'll let them introduce themselves later, but we're going to focus on diving deeper into the Amazon Nova family of models, what are their value proposition, and towards the end of the session, we'll have TP-ICAP presenting a customer success story in terms of how they have used these models to solve a business use case. Okay, so let's get into it. When we talk about Amazon Nova Foundation models, we have a series of models which go from micro to light to pro, and the premier is coming soon. And as we go from micro to premier, the size of the model grows, hence the quality of the model output also grows at the same time. And we will also see that when we go from micro to premier, micro is the fastest, and as we go to the bigger and bigger models, the latency would be, let's say, comparatively slower, but micro would be the fastest in this category. So speed and latency, these are the two things we'll keep coming back to this in this presentation. So we have text understanding models, which is micro, light, pro, and premier. Then we have creative content generation models as well, which is Amazon Nova Canvas and Amazon Nova Reel. Amazon Nova Canvas is an image generation model, and Amazon Nova Reel is a video generation model, a short-form video generation model, to be specific. Recently, we also launched our speech-to-speech model, which is Amazon Nova Sonic, and we'll go into these models in deeper as we progress through this session. So let's go deeper into the Amazon Nova understanding models first. When we talk about the micro, light, and pro models, all of them come with a context window. So micro has a 128K context window. Amazon Nova Lite has a 300K context window, and same goes for Pro, and Pro will soon have 5 million context window as well. They are all multilingual. Nova Micro is basically a text-only model, but Nova Lite and Nova Pro are multimodal models, which means they can accept text as well as vision modalities as an input. Talking about Amazon Nova Micro, what you see on the screen right now is a list of benchmark studies which we did against comparable models like Gemini 1.5 Flash, 8B, and Llama 3.1 8B models. And we can see that the Nova Micro model consistently performs at par or even better in this category of model with the comparable models. The interesting bit on this slide is the latency. If you look at that, 329 tokens per second is insanely fast latency, which Amazon Nova Micro models provide, and also at a very, very cost-effective value proposition. Going from micro to light, we did similar studies for light as well, and these are how the benchmarks are looking like. We have divided the benchmarks into the task categories, which is like we see visual intelligence, agentic workflows, and the general text understanding tasks. And again, you will see that the Nova Lite models actually, they either outperform or perform at par when we compare it to the other models in the same category. Again, if you look at the latency numbers, 297 tokens per second is blazingly fast for this category, because if you look at the comparative models, they have much higher they have much slower token per second count as compared to Amazon Nova Lite. Going from Lite to Pro, we again did a similar kind of benchmark study with the Pro models as well. And again, we have divided the benchmarks into 3 different categories. We see the task category, we see the visual intelligence category, and the agentic workflows category. And you will see that Nova Pro has been compared against models, flagship models like Claude 3.5 Sonnet V2, GPT-4o, Gemini 1.5 Pro, and Llama 3.2 9TB models. And again, you will see similar kind of pattern where we see that Nova Pro is performing at par or even beating the benchmarks in certain categories. And it's again coming at a very latency and cost-effective value proposition of 129 tokens per second at a very, very attractive price. So with that understanding, we actually also, let's look at some of the third-party industry-leading benchmarks and how the third-party benchmarking companies and organizations have actually used and what kind of evidence they have seen with Nova. So this is an example of Trellix, which basically does threat detection using AI. And what they do is they process billions of events every second. They put all of that events into sort of a vector store, and then they try to use AI to do automated threat detection on the events. And they found that Amazon Nova Micro is at least 3 times faster and almost 100 times more cost effective while providing the same decision-making qualities as they could get from Cloud 3.5 Sonnet. And this is a P70 benchmark which we are looking at, which basically reinforces the point which I was showing in the previous slides, where we see that Nova models are actually giving a very good cost and price performance when compared to other models in the same category. Let's look at another benchmark. This was done by a third party, which is artificialanalysis.ai. And what they found out is that they compared all the models across the spectrum for output speed, which is output tokens per second. And what they saw that Nova Micro and Nova Lite were leaders in this category. We can see that Amazon Nova Micro was clocking 338 tokens per second, and the second one was Nova Lite, which was 307 tokens per second. And you can see the other competitive models as well, and they are not even close to where Nova is performing in terms of the output tokens latency. Even the Nova Pro is also actually a pretty strong competitor here. If you see, the numbers of Nova Pro are also very promising. So I talked about the cost aspect and the latency aspect and how fast these models are, right? But when we are doing this, we are not leaving responsible AI behind. From the ground up, from the core foundations of it, we have put responsible AI practices in place when we are building these models, be it any kind of bias detection, be it transparency, hallucination checks, robustness, explainability. We have added all of those. We have used all of those practices in building these models so that these models actually are performing well on all the responsible AI dimensions, which can help you be more confident about using these models. Another interesting part is the indemnification of model outputs. So what we do here is whatever output Nova produces, Amazon provides you an indemnity protection on that. What that means is that if the model produces an inappropriate output, Amazon or AWS will provide you support in terms of covering the indemnification costs for it. This is just an example of a Nova Pro model where we uploaded a short video of a football match, and we just said describe the video. And you can see on the right the kind of description which the Nova Pro model was able to produce. And if you look at the description, it's very nuanced. Not only just depicted that it's a football game, it actually found the player's position, how they are moving, how fast and how slow they are moving, what kind of pass they are making. A lot of interesting and nuanced details about this particular video was captured through this particular model. Let's look at another example of handwriting. So on the right side, you see an image, which is basically a handwritten image. We provide that image to a Nova model, a Nova Lite model in this particular case, and we ask the model to extract the content of this image into a JSON structure. So it takes the image, processes the output, processes the image basically, and gets the output in a JSONified representation, which actually shows you that it's not only that it can understand computer-generated artifacts, but it also works very well on handwritten artifacts, handwritten images and whatnot. So if you have a scrappy whiteboard diagram, try throwing it to the Nova models and let it extract all the meaning out of it in the structure you want. Another interesting example of a more complex use case of same multimodality, in this case we are showcasing Nova Pro here, where we are going to upload a very complex machine diagram of a liquid control system flow. It's a highly complex machine diagram with lots of boxes and arrows going everywhere, and we ask the Nova Pro model to extract the information out of it. And we could see that it was able to extract all the details of different components, how the components are talking to each other, and then we asked a follow-up question. How would you improve this process? And it actually, wonderfully, it also provided some suggestions in terms of how we can improve it in terms of enhancing the safety features, automation control, documentation and training and whatnot. So you see, the Nova models are not only trying to extract the information, but they also understand the kind of information which is being extracted, understand the context, and based on the context, they can also help you provide some suggestions in terms of improving the existing process or the existing input which you have supplied to. That's all I wanted to present, and now we'll pass it over to my friend Antonio to take it forward.
Thank you, Vikesh. Also known again I'm Antonio. I work as a principal generative AI solutions architect in the Amazon Bedrock team. And we have been seeing a lot of interesting information about the Nova models, but also I wanted to highlight a few aspects on how you can customize those models with your own data and how can you tweak the behavior of those models using your own information. And one piece of, or a technique or one piece of aspect that is important to cover is how to pass all of your information in the context, taking advantage of the big context, the big input that we can have in those models. And you can see the sizes that were referred before by Vikesh. And the interesting thing is that even when you have 1 million in the Pro, and we are expanding soon to 5 million tokens in the input, where you can potentially have a lot of information added in the context right away, if you see the accuracy that we are maintaining on that info is actually very high. You see the stats there from the needle in the haystack, which is a metric that let us know how much of noise we have in the information that is being blended in the context when we are trying to make questions to the model based on that. So it's really high quality, no matter the size of the context that you are passing to those models there. Another common way in which we normally customize the behavior of those models with your data is doing fine-tuning. So today in Amazon Bedrock, you can customize the Amazon Nova models. You can do it with Nova Micro, you can do it with Lite, you can do it with Pro, using your own data. And with that, you get a fine-tuned version, your own customized version of Amazon Nova with your specific information in your organization or your tags that you are interested in. So that will boost your accuracy and will basically make sure that you are aligning these to the domain that you're working on. Another way that is very popular these days to do customization is doing the process that we know as model distillation. So today it's possible to do model distillation in Amazon Bedrock from Amazon Nova Pro, and you can basically take this information together with your prompts, with your own data, for having a smaller footprint model with equivalent performance to the Nova Pro. So you can take it as Nova Pro being the teacher, Nova Micro or Nova Lite being the student, and by using your information you get the same quality of Nova Pro in a model that is faster and cheaper for you to use. So it's a very popular way in which our customers are customizing today. Now, those are just examples of how we have been using the understanding models, but very recently we also released other ways in which the models are going beyond just giving you an answer to actually acting on your behalf, so actually taking actions on your behalf. So very recently we released a feature that is called Amazon Nova Act, which actually lets you operate a UI, a virtual machine normally, where you give control to the model to take screenshots and make actions on your behalf. So you can imagine this as being a trained model that is already ready to perform actions directly in a web browser or in a UI, in a CLI, or even do some coding on your behalf. Just to see a quick demo of how this looks, we can see this example with a shipping system that we have in SAP. And we have a prompt here where we are saying, I want to change, in example, the address for a given shipping order that I have with a given number. So just by submitting this prompt, what you are going to see is that Nova Act is going to start by saying, okay, let's think about this problem. I think that I need to do this task. So I need to, in example, go to click the Manage Sales Order button. In that bounding box that is located in this place, I have to go and do a change in the sales order number, whatever, the number that I indicated in the prompt, and then I have to change the address to the place that the user told me. And as you can see, the model is taking screenshots and doing the actions on your behalf. It's actually moving the mouse, it's doing the clicks, it is writing what it needs to write, and so on and so forth. It's not only obviously for SAP, it actually works for any kind of interface, any kind of information that you have in the interface, like a web browser, your intranet, any internal system, anything that you can have in an operative system, typically an Ubuntu, a Windows operative system, where the model can operate that virtual machine on your behalf. Here we see that it's actually opening the order that I indicated. It will look for the chain chip details, so that it will actually update the address that I was telling it. And it will, for doing this, it will move the mouse again, it will click, and then eventually it will take the house number, which is the parameter that we want to change here, and it will automatically change it for the new number that I added, and it will save the record, and so on. So you can see it is like having an employee automated, fully automated in this case, for doing analysis. It's able to do very smart things with Excel spreadsheets, in example, combining your own systems, and so on and so forth. Now, Other types of models that we saw before that are very interesting as well are the creative content models. So we have today in the family of Amazon Nova models for generating images, which are Amazon Nova Canvas, and models for generating videos, which are Amazon Nova Reel. With Amazon Nova Canvas, you can actually generate images like the ones that you see on the screen. You can define, obviously, the aspect that you want for those images from a prompt. You can also pass an initial image if you want to do in-painting or out-painting. So if you want to remove the background, you want to replace it, you want to replace an object in the image, and so on and so forth. You do everything with a simple prompt where you indicate the style of the image and so on. So you can also get automatic watermarking on that image so that you can trace the image when it's generated by this model, so you are aligned with the responsible AI policies and regulations that we have as well. On the Amazon Nova Reel, you can do an equivalent task, but in this case for generating video. So you can do text to video, you can also do image to video if you start from an image and ask it to do an animation and, on a certain behavior. You can do camera motion control, so you can indicate it, example, do a zoom, take an aerial shot, anything that you want to do in that take that you are generating. And obviously everything is coming with the built-in safety and responsible AI controls. Now, when we talk beyond images and video, these days we're also talking about speech. So interacting with voice is very popular among our customers, and these days these models are actually capable of interacting also in going from speech to text or speech to speech. So very recently we released Amazon Nova Sonic, and Sonic is a state-of-the-art model for working with audio, for working with speech in this kind of task. So it is a model that has a context window, as you see, of 128K tokens in the inputs. Right now it supports English. It brings voices, different voices, mainly in American and British accents for English. It is going to bring additional languages also very soon in the coming months. And you see that it also is going to be supporting fine-tuning soon, which means that you are also going to be able to pass your own data so that you tweak the behavior of the audio model that you have. We are going to listen at a very quick demo on where we have a call center analytics in real time using the Amazon Nova Sonic as the agent that is speaking on behalf of the customer service, automated customer service model that we have there. So let's try. I hope that it hears well in the audio.
Hi, is this any telco customer support?
Hello, yes. This is any telco's customer support. Can you please provide your phone number so I can look up your account information?
Sure, yeah, it's 510-123-4567.
Thank you for providing your phone number. I've retrieved your account information. How can I assist you today?
Why is my bill this high? It's ridiculous. How are you charging me this much?
I understand your concern about the high bill. Let's look into it. Your current bill is $108.45, which includes a $70 plan cost and $38.45 in international roaming fees.
Wait, but I travel internationally a lot, so I need a plan that won't have international roaming fees.
I found a plan that might be suitable for you. The Global Connect plan costs $85 per month and includes unlimited.
Okay, I'm going to stop the demo here because of the time, but as you saw, we are basically interacting with voice in real time with this user that was calling our call center, and we are also taking insights in real time because the model has the ability to do what we call tool use or function calling. So we can actually receive an input in audio and we can take an action, like an example, measuring what is the sentiment that we have for this customer, deciding what is the best next action that we can recommend to this person, and so on and so forth, and come back and give an answer. It also supports that you interrupt the model when it's speaking. So in example, we just say, yeah, but hold on a minute, I wanted to actually say this or that. The model stops speaking so that you actually listen to the new prompt that you're passing, and so on and so forth. So you're going to be hearing more about Sonic and the integration that it has with the broader Amazon Bedrock ecosystem very soon as well.
Hi.
Now, all of this is very interesting, but if we don't see it in reality, it all stays in a PowerPoint presentation and some demos that we're showing you here. So for that reason, we want to invite Scott Harding, who is AI data and technology lead from Taipei ICAP, and is going to tell us about the success story with Amazon Nova. So welcome, Scott.
Thanks, Antonio. It's great to see what AWS are delivering for their customers in this space, particularly in such a short amount of time. So I'm here today as an AWS customer to talk about how we use Nova models at TPI-CAP. In particular, how we've used them to dramatically decrease the time and effort it takes for our procurement team to process vendor contracts. So I'll talk you through what life looked like in our procurement team before we started this and how that compares to today. So that includes a demo, a walkthrough in architecture, and then a review of the impact. So let's look at the business problem we're trying to solve today. When TPI-CAP engage with a vendor for a new service, a number of contracts are exchanged. These contracts need to be processed. So the procurement team are tasked with reading through these contracts, extracting information and documenting them into a central repository. In our case, that's ServiceNow. So somebody in the procurement team would be reading through this contract, extracting the types of information in green. That can be simple information, such as supplier names and addresses, down to more complicated information around service level agreements and cancellation policies. So somebody would read through this, copy and paste it into a form, which is shown on the right-hand side over here, and then submit that to create records. It's a really tedious task, and in most cases doesn't actually require any specialist procurement skills. So time spent on processing these contracts is time taken away from negotiating with vendors, analysing our spend, and making us more efficient as a business. We also have the challenge regarding the formats of contracts. So in some cases, like we have here, the contracts aren't written in English. This example is written in German. We don't have any native German speakers in our procurement team, so it makes it complicated to process these. In most cases, they're just never processed at all. The example on this side shows scanned copies of contracts. So this is when vendors are sending images of contracts. They don't have selectable text in, so whoever's reading and processing that has to manually type that information out into the form. So again, it takes a long time to process and it's complicated. So our current state looks like this. We've got poor old Sue up here in our procurement team, looking very stressed out with her hand on her heads. She's working through piles and piles of unprocessed contracts. And she's also getting asked to do lots of other stuff in her team that she should actually be working on. It's worth noting that Sue here was actually generated using Nova Canvas, which Antonio demonstrated earlier. So just an example of even putting small PowerPoints together like this of where you can sort of use this technology. Ultimately, what that leads us up to is having a big backlog of contracts that are never processed because it takes too long to do and it's too complicated. This means we have a really poor visibility into spend, so we're not making good decisions around where we're spending money as a business. So we sat down with our procurement team and asked ourselves, could we automate this workflow using AI? And we set 3 high-level business objectives. The first one being all vendor contracts should be processed and stored in a central repository. Data should be complete and accurate, and the process should require minimal human effort. So I'll just touch on the last 2 here. So data should be complete and accurate. At the minute, Sue's got all of these contracts that she's trying to process, and she's rushing through them. By human nature, she's making mistakes. And that's polluting our data set in ServiceNow. So then that means we get bad analytics. The process should require minimal human effort. So it's taking Sue on average between 20 and 30 minutes to process a single contract. At one point, we had hundreds and hundreds of contracts in the backlog. So you can imagine how long it would take her to process all of these contracts. It's also not a particularly very fun thing to do. So we've built a tool in AWS that automates this workflow start to finish, which I can demonstrate to you now. I did ask if I could do a live demo of this, but I was advised against it by my friends at AWS down here. And given my track record of live demos, and particularly AI ones, it's probably not a bad thing, to be fair. So we've got our contract here, which I showed you a snippet of earlier. And this has got all of the information that we need to extract. In total, there's around 65 different pieces of information that we need to catalogue. So what we've built now is a portal that Sue can log into and upload these PDFs to be processed automatically. So here she goes in, she uploads her file, and that goes into a pending state down in this table below. So in the background, we're using Nova models to extract that information directly from the contract. We're providing context for it to understand the types of information and how to extract it. That then goes into an answered state. So this gives Sue an opportunity to review those answers that it's given. I'll just pause here 1 second. So a large majority of the information on the screen here and in the fields that Sue's watching has been extracted directly from the contract. There are some fields that have been inferred. So we've got information here around start dates, currencies, total contract cost. That's all taken from the contract directly. There's other fields that we've got over here, and I'll just try and highlight some of these. So the TPI cap procurement lead, that's not in that contract, and it never would be. That's something we, as a firm and as a team in procurement, assign. So who's the owner of this contract in the procurement team? What we've done in this case is extracted all of our old ServiceNow records into a knowledge base in Bedrock, and we're using AI to discover who's the most appropriate person in this case to assign to this contract. So not only are we using AI Nova models to directly extract information directly from the contract, we're filling in the gaps as well from there. So Sue's now got the opportunity to review the answers, and then when she's happy, she can hit submit. So she submits these, that creates a record in ServiceNow. She's then able to see that record from our main portal. So this is what that record looks like in ServiceNow. So what we've got here is a reduction in time it's taken Sue to process that contract. That was taking 20 to 30 minutes. That's now down to 2 to 3. It's also handling the complexities of the use case as well, which I demonstrated earlier. So foreign language is something that the Nova models are particularly good at, and also regarding scanned images with bad data quality. So I'll go through the architecture that kind of gives you an idea of how we're actually solving this problem start to finish. We'll follow the numbers round. So we start at number 1 on the left-hand side over here. Sue logs in via API gateway. She's authenticated. We know who Sue is. She's allowed to access this service, and she's given a token. She's then able to upload that contract to S3 using a pre-signed URL at number 2. That in turn triggers a message on an SQS queue at number 3 here, and then a series of Lambda functions are executed on the back of that. So this is where the AI part starts to happen. At number 4 here, we do a first pass using Nova to extract the information from that contract. When we've got those answers back, we use the data discovered from the contract to then query the knowledge base to fill in the gaps. So that's the information that's inferred from old records, which I explained before. So we'll use information such as the vendor name on the first pass to then query the knowledge base to discover who might the TPI cap procurement lead be. And there's other information that we discover from there as well. When we've got all of these answers, they're all stored in DynamoDB. And that's what Sue can see on the UI when she's validating the answers. And the last thing at number 6 here is Sue clicks submit. That creates a record in ServiceNow. Importantly, that also updates our knowledge base in Bedrock. So that record that she's just created is then used as a reference point for future contracts that are processed as well. And this is a look at the solution impact. So this shows what a difference this has actually made. We've got an 85% reduction time it takes to process these contracts. So like I said, it was taking Sue about 20, 30 minutes to process a contract before. Now that's down to 2 to 3. Since we've launched this service, we've processed over 1,000 contracts. We've got improved visibility into spend, and the accuracy of our data has improved. And the screenshot here shows that data sort of brought to life by some ServiceNow analytics dashboard that our procurement team have put together. So this is now using that data that we've extracted from these contracts for us to allow to make good choices around where we spend money as a business. This is all at a really low running cost. It costs us hardly anything at all to run this service. We did actually look at one point of hiring a third party to come in and manually process these contracts for us. That's something we haven't had to do now, so we haven't had to pay for. And ultimately, it means our procurement team are spending more time on added value tasks, so they're not just sat around processing contracts all day. And Sue's back, and she's looking rejuvenated. She's a happy worker, big smiles, no contracts to process. So we've got happy Sue. So she's either sitting there, not processing contracts, making us more efficient, or she's working from home, walking her dog, or doing whatever Sue likes to do at home. She's got lots of time on her hands now. So why is Amazon Nova important to us? So as an AWS customer and a consumer of AI, these are the 4 things that we're looking at in terms of model selection. So which model are we selecting to solve this particular problem? So intelligence is really important for this use case. We need to make sure that the answers we're getting back are as accurate as possible to get that data quality good. Latency isn't such a factor for us. It's not a chatbot. We're not needing real-time information. So if we have to wait a little bit longer to get a good quality answer, then that's a better story for us. Cost is always a factor. If we can run this service for as little cost as possible, then that gives us scope to do more with AI. The business aren't put off with AI being expensive, for example. And scalability is the last one. And this is regard to the quotas for these models when you're invoking them, which is shown on this data here. So this service was actually originally developed using Anthropic 3.5 Sonnet, and we migrated it when the Nova models were released. The top level of data here shows the quotas per minute. So you can see the Nova models, because they own the whole value chain for this suite of AI, they're able to better fulfill our scaling needs. This service sits in an account that's competing with lots of other AI services for these quotas. And the last bit is cost. So when looking at costs, and this is quite typical of some of the Amazon services, there's loads of zeros all over the place, so it looks really cheap. Who cares what model you're picking? It does start to make a difference, though. Like I said before, we've processed over 1,000 contracts, and the expectation is that we'll carry on using this to do more. So with using Nova models for this particular service, we're able to run it with a lower cost, get the same quality of data, and we're not having problems competing for quotas with different models in the account. So what's next? What's the future for us look like? In terms of this particular solution, we're looking to build on the success we've already had. So one of the examples of that would be evaluating terms and language used in contracts. So do some of these contracts contain terms that don't work in our favour or that we would deem non-compliant? And can we use that to then renegotiate with these vendors to put us in a better foot as a business? Another example we're looking at is deploying virtual workers into the team. So this is looking at agents, which Antonio touched on earlier. So we could deploy a virtual Sue into the team that could be assigned tasks that would be carried out autonomously. The last point I'd like to mention here is our recent launch of our AI and Innovation Lab at TPICAP. So the idea behind this is to expand the adoption of AI throughout the business. And that would be working with technical teams like developers to enable them to build their own services in Amazon, or non-technical teams like corporate services and our procurement team like I've showed today, where we're building on behalf of services for them. And just to close out, I'll invite Antonio and Vikesh to come back to the stage. There you go, Antonio.
Thanks, Scott, for sharing those insights with us. I think that is a very interesting use case on how to use Amazon Nova. So that's pretty much the information we wanted to share with you today. And if you want to get started, you can go and scan this QR code. We'll probably get off the way. Run your evaluations, benchmark, obviously. We are firm believers that there is not a single model that will fit all of your use cases. So we really think that there is an evaluation that has to happen more and more for every use case that you are developing on. And test about Amazon Nova on the Amazon Bedrock Playground. So you can go ahead and try your prompts, try with your own data, and see what kind of performance are you getting. We also have prompt guidance specific for Amazon Nova. Every model has their own guidelines on what is the best way to prompt those models and get the most out of this. And you also have some quick start guides for getting started with the Nova models in general, with all the family of models that we shared before. So with that, we want to recommend you also to go to skillbuilder.aws so that you can learn more and get some free accounts so that you can get training, additional training on all of the services that we have in AWS. And thank you very much for your attention. Don't forget to fill the survey, and please leave the headsets in the chair when you're leaving. We are going to be available outside of the auditorium for any questions because there are more sessions happening here. Thanks for your attention.
You're my broken love. So come on, let's